All right, guys, back to the sales and location problem. We had earlier in a couple of videos, we had some sales of a product over 10 weeks, and we wanted to see if there's any difference according to the location, L1 and L2. Guys, remember the null hypothesis was the mean for L1 is the same as the mean for L2, and when you see that, just think that that means that the difference in the means is equal to 0. The alternative hypothesis is the mean of location 1 and mean of location 2 aren't the same, indicating that one location yields a higher sales volume than the other. And that just indicates that the difference in the means is not equal to 0. Guys, we're sitting at alpha equal 0.05. Now, in preparation for this video, a couple of things. I noticed that I made some typos from the original data set. I'm not as concerned about that for illustration purposes because again, as long as I'm consistent with the data set throughout the problem, that's not a big deal. Now, if this was an assigned problem, it clearly would be. But I made another mistake. I noticed that the test statistic was actually negative 3.746. I transposed the first two numbers and used negative 3.476 to calculate the incorrect p-value. So the p-value should actually be 0.0015. And guys, just so there are no confusions, let me show you how that would work out. So I just go to Stat, go to Calculator, go to T, and degrees of freedom wouldn't change. It'd be 18. And we want less than negative 3.746. Guys, I almost did that again. 3.476. Compute, multiply that by 2. And when you do, you're going to get rounded to 4 places, 0.0015. So sorry for the confusion. Really not confusion. It's just a lame moment. And I transposed two numbers. So, but everything I did was solid except for transposing the numbers. All right. Back to this. Our confidence interval was negative 36.99 to negative 10.41. Please rewatch the video if you have any questions about confidence intervals. And our pooled variance was 6.33. All right, what I want to do now is demonstrate how to work this problem using Statcrunch, using technology, which is typically the way if you worked for this particular grocery store and you were wanting to examine this and report it maybe to regional managers or marketing or whoever, you wouldn't most likely calculate the critical value and the p-value by hand. You would use some level, some mean of technology. Statcrunch may not be available to you if you do get out and run into something like this, but SPSS and the big statistical software packages work a lot like this. So I guess without further ado, as they say, let's work this out. So you can see that we have our sales in the first column, our location in the second column, and we'll see when we start to run our T-stat2 sample with data, which is where we'll go to conduct a two-sample independent t-test. We run into a problem. And the problem is it wants our values from sample 1 to be in one column and our values for the second sample to be in another column. That's not what we got. We have two columns, but one column is sale and one column is location. So we have to do a little bit of manipulation of the data to start this problem. So guys, it turns out it's something very, very simple to do. Go to data. Go to arrange, go to split. This will be something you'll have on your final exam. So get it in your notes and get it on your cheat sheet. I think for the final exam you'll get a couple pages of notes. I think that's the way to work out. So anyway, let's go split. The first number you want to choose, first column, will be the quantitative variable, which is sales, and then your second will be the location. All right, so compute, and you can see that we have L1 sales in one column and L2 sales in another. So guys, we are now ready to conduct a t-test. to sample with data. So we have L1 and L2. Guys, for this class, we always assume that we have equal variances, so let's do the pooled variance. I may get into that a little later, but assuming we have equal variances moves smoothly into ANOVA. So we'll go with this. Mu1 minus mu2 equals 0. Mu1 minus mu2 not equal to 0. All is good. Let's compute. And just like that, wham bam, thank you ma'am, x bar 1 minus x bar 2 is negative 23.7. Our pooled variance, which kind of smashes our sample variances together and gives us a pooled, combined variance. The degrees of freedom are 18. Our test statistic is negative 3.746, not 3.476, as I tried to make it. Our p-value is less than 0.05. So we get a p-value less than 0.5, so we get statistical significance. All right, gang. Thanks to Megan, I believe, for pointing out how we can go back through and not enter everything in again. So Megan, many thanks for figuring that one out. We can go ahead and do a confidence interval compute. And you can see that the left limit is negative 36, or no, lower left. Either way, negative 36.99. The upper limit is negative 10.41. What's most important when I look at that in terms of statistical significance is that we have a negative format. I talked about that in the last video. So that tells me that statistically speaking, that the mean difference is negative. So the mean sales for location 1 is statistically significantly lower than the mean sales for location number 2. So location number 2 wins out as having the highest. Well, guys, this is one of those situations where I couldn't make it hard if I tried, and of course I never will. But that's really all we got. That's the way we conduct a 2-sample T confidence interval. All right, take care.